Fernando Sarría. Uh, he's the CEO and founder of DENODL. Fernando is in fact an architect by training, if I am not wrong, but who has developed a highly interdisciplinary career at the intersection of technology, innovation, and engineering. Over the years, his professional path has evolved, leading him to create and develop technological solutions to address real-world challenges through advanced sensing systems, electronics, IoT technologies, and data analytics. And through DENODL, he leads the development of innovative monitoring solutions for agriculture and environmental management. And one of these innovations is the HYDROBALL sensor series, which provides detailed information on soil water content, water potential, and other variables, helping farmers and researchers make better informed decisions about irrigation and crop management. And for you, SUSTAGRI students, I think that Fernando's career, is a great example of how technical training can evolve and how innovation often emerges from combining knowledge across different disciplines. So please join me in giving a warm welcome to Fernando Sarría and listen to him. Fernando, thank you very much, and please go ahead.
Okay, so thank you very much for your introduction. I think that you can explain better than me the DENODL project and my career. So thank you very much. Thank you thank you to you and to the Public University of Navarra. So my English is not the better, but I try to explain our project as better as possible. Okay, so I share my screen to illustrate my this discussion. Okay, so yeah, I think that you are watching my screen.
Yes, perfect.
Okay, perfect. Thank you very much. So thank you again. Our project, the DENODL project, as Javier explained a moment ago, is a mix of sensorizing system, SaaS platform, and advanced analytics based on artificial intelligence. So prescription systems for agriculture, landscaping, sport turf, and ecosystem management. We have use cases in all these areas. So I think that the formula is common use for another companies, for another technologies to mix the sensorizing systems and the artificial intelligence. So I think that the difference could be in the focus of the product, the focus of the technology. No, this is for me the big difference. So as we and everything understand here, the first step is to watch what happened exactly in the soil, mainly in the soil. Show this information in the platform, not only graphs, basic analytics, alerts, etc. And after that, you analyze this information with artificial intelligence and show to the user via quality but not quantity way. So it's more important to give to the farmer the information of what must do better than, okay, you have a water content of 23%. So it's better to give the information, practice information, exactly what must to do. It's not the data of the sensor is not a value, but it's by itself. Okay. So all of our sensors, I will introduce in a moment the sensor that we are working on. So, but all our sensors give at least these measurements: the volumetric water content, the water tension or potential, the soil temperature, the apparent conductivity, and very important, the electrical conductivity of the pore water. So this is very important because the apparent conductivity, as you know, is a conductivity of a mix of the soil, the salts, the water. But really, the roots of the plant take the salts, the macronutrients, and micronutrients from the water. So it's more useful to give the apparent the conductivity of the water in the solution. Okay, so this is a new measurement that we launched at this December 2025. We are working in three formats. The first one is the HYDROBALL. As you know, at the top left of your screen is a very one of the keys of this sensor, this probe, is that it's absolutely autonomous. It's not necessary to link by a cable with a data logger because the sensor, the unit, manage the power, the energy, the transmission via LoRaWAN or via NB-IoT or LTE-M, and the measurements. For example, the HYDROBALL takes four capacitive measurements, two of the soil and two of the ceramic piece that you can see at the bottom of the unit. So this couple of sensors, capacitive sensors, give us the opportunity to distinguish between the source of the dielectric. As you know, high frequency in a high frequency measurements means that we are more sensible to the water content and less to the salts content, and lower frequencies mean exactly the opposite, no? More sensible to salts and less sensible to water content. So this is the key for obtain the conductivity of the ceramic piece where the water penetrates in a controller environment, okay, and the soil parameters, okay. The device take the measurements around it in a torus way, more or less, and at the bottom in the ceramic piece, the parameters relating to the potential and electrical conductivity of the pore water. Okay, the second sensor is the HYDROBALL twin. As you can see, okay, the image is not the best, okay, but okay, you imagine it. So the HYDROBALL twin is like two HYDROBALLs linked by a cable, okay. So the point of the HYDROBALL is, for example, for sports turf or for, I don't know, lettuce, tomato, is okay because it's not necessary to introduce in the soil in 20 centimeters. So we have no problems by transmitting from 20 centimeters of depth. But for example, for sensorizing trees, where we need to measure at, I don't know, 50 centimeters, 80, or more, is this unit, the HYDROBALL twin, allow us to take the measurement as the depth that we want until 2 meters is the max length of the cable, and the top unit is a unit that has the batteries. The battery is very easy to change. The duration is about 1 to 2 years. It's a 4 simple double A batteries, very easy to change. And the top unit, as I explain now, it has the batteries, the transmission, and the main control of the unit. So it's the top unit is in the soil, in the first centimeters of the soil, or over the soil. I don't know, in a link to a tree or a wood pool. I don't know. So this is good for certain crops. No. The third one is the hydrostick. This image is not the real image, but we want to hide for the moment the final images of this unit because we are now with process of protection, no, industrial protection. So this is the HYDROSTICK is a very new sensors because it's absolutely modular. So you have, it's a blade, like for example, the Centec sensors, okay? But the difference is absolutely is modular. So you have the first module is a cylinder, okay, that contain the batteries, contain the transmissions and the main control, and you can add like a reflex camera objectives. You plug the sensor units, and you can combine these sensor units, okay, in a sensor of only soil parameters like volumetric water content, electrical conductivity and temperature, or combining the potential and soil parameters, or NPK sensors. Okay, this is very important because the NPK sensors that we are now under develop, okay, so is the first sensor that is capable to take the salts directly from the soil. So and it's a unit that like the hydro is not necessary to link to a data logger, etc. So no cables. It's very easy. Okay, so it's not necessary to extract the device to change the batteries because you open the cover and extract the batteries unit, change the batteries and plug in again. Okay, so you have in the right at the top a professor of the University of Florida that is explaining how the HYDROBALL is the first sensor in the market that is capable to perform analysis that previously only is possible in a laboratory. Why? Because we are mixing the signals of water potential and volumetric water content. So this combination gives us the suction curve in real time. This is the one of the keys, no, of the sensors. All of these technology are developed by us, by our company. We don't integrate sensor of third parties. All the technology are our technology. Okay. Okay, we can see here some use cases. Okay, this is the images of our platform, for example, in a farm in Malaga, here in Spain on the south. Okay, you can see here in the left top image, okay, the parameters. We cannot see the electrical conductivity of the water in the pore because this version of the HYDROBALL is the first one. So this measurement was not integrated when I take these images. So we can see in the red graph is the volumetric water content, and the blue one is the potential. So we can see the irrigation each 2 days. So in each irrigation event, you can see that we are very close to the saturation. After that, the water falls. Obviously, there is a lixiviation problem here. Okay, so and after that, in this point, we keep in the field capacity. So after that, you can see the night, the day with evapotranspiration, and the night again. So we can see how with a volumetric water content of more or less 20%, we can see the potential about from 20 to 40 kilopascals. But when the volumetric water content falls only to a value of 18, the potential increase the value to 140 kilopascals. So we can see here the difference, depending on the texture of the soil, obviously, the difference that of the status of the soil from a hydrate point of view, with a low differences for volumetric water content. So You can see here in the application screen the suction curve is the purple points, and the red one is the synthetic curve of the selected soil that is a sandy clay loam soil. Okay. This is our other use case in a farm in Zaragoza. It irrigates, I don't know the name in English, or riego por manta. Okay, but it irrigates, it's 2 weeks. Okay, they open the doors, the water falls in the plot. Okay, we have here saturation. After that, the point of the field capacity, and after that, the first week, the potential is okay, but the second week is increased its value dramatically. So we can see here the same than before. How the purple points, that is the suction curve that the hydroball takes, how to fit with the synthetic curve, in this case of a loam soil. Okay, so, and using by the bibliography, you can see here the typical data points of this texture, no, that we must test with the real graphs. No, for example, in here we can see the field capacity in 28% for a loam soil, and okay, you can see here in this graph that in this case it corresponds with the real data. Okay, so it's very interesting how in this point how we have more or less around 16% of volumetric water content, and the potential is about 150 kilopascals, and in a rainfall event, the volumetric water content increased only 2 points from 16 to 18, and how to the potential falls to a value of 18. So this is possible only to see if we have a probe that is capable to take all these measurements. So I think that this one of the keys of our sensors is to give good information in real time dynamic information about the behavior of the soil, and to understand how can we improve the management of the soil from irrigation point of view, etc. No? Okay, so this gives us the opportunity to have redundancy, because we have the potential and the volumetric water content, a combination, interpretability. So because we have the suction curve, we have many data to learn about the soil dynamics. So real-time generation of the suction curve and estimation of the soil texture through the behavior of the water. No? So finally, this, as we explained at the beginning, really the sensors. Imagine that you are a farmer, that you have, I don't know, 50 sensors in your plot. No, each sensor is capable to give us 5 graphs of data. So you cannot waste time every day to watch 250 graphs per day to do your decisions. No, so it's necessary an expert system that interprets all the data and give us the information, useful information for the farmer or for the greenkeeper, for a golf course, etc. No? So this layer is named DENODL analytics, that we will present this August. Okay, and this layer is composed by four implementations. The remote sensing is a satellite image, and the disease prediction, the simulation and of irrigation, considering the water prediction, and finally the automatic reporting. The automatic reporting is a PDF that the farmer will receive in his email or in his phone, where the artificial intelligence informed the farmer by a quality, not quantity point of view of what happened with my farm, with my crop. Okay, so this is on a screen capture. Okay, this is the satellite image, the index NDVI. Okay, so we mix the data from the sensors and the satellite image to accommodate the satellite index to the value that the sensors take directly from the soil. No, so we can see the satellite image in different dates. So this is more information for give to the user and to the artificial intelligence to manage the decisions. No? Okay, this is the irrigation hydraulic analysis and irrigation prescription and simulation. So the system calculates the evapotranspiration, take the data from the sensors. You must introduce your schedule of your irrigation, and the system gives you the information. For example, how much time are you under refill point or overfill capacity, etc. So the system consider the weather prediction. So this is, I think, this way to schedule the irrigation, to do the planification in a very effective way. No. So the second point is the disease prediction. So depending, we have in our catalog about 70 diseases. Okay, so considering the climate prediction, so the weather prediction, and the plant and variety, who is sensible to some disease or other disease, taking the historical data and the future data, we show the risk of your plants to have problems. Okay, so and at the right of the screen you can see the typical tool is basic. This is not a new. I think that you take the photograph and the system analyze what happened in your plants. No, I think the new point is the left square in the screen. Okay, and finally, and I will finish now. Finally, you can see here an example of DENODL report with the recommended irrigation time. Sorry, and this is prediction. So the system take all the information and show to the user. So for me, the important thing is that these reports show to the user the areas where we can find a risk. For example, okay, be careful because at 5 p.m. you can have problems of stress. No, so we recommend an irrigation at this time. No, so this is the point. No, this is the purpose of this report. No, okay. All these filters are a part of the DENODL analytics. Okay, so we have the platform when we show all the data, the suction curve, all the information, the digital twin of your farm, your installation, and this layer, the nodal analytics, will give you this information that I explained. So we are working, until now, we are working in many countries in Europe. We are working in the Emirates also, and we started to present our products in the United States and in Mexico. So thank you very much. This is my phone and my email. If you want to contact me,